if less than significance level, reject your null hypothesis. And so then this is how we get to be able to prove that our alternative hypothesis is true, is that our goal with all of these processes is to reject the null hypothesis. So your goal is to go through all these calculations. You have to determine whether it's one-tailed or two-tailed to know which calculations that you're doing. But that once you get there, you get this final p-value. And this p-value is then compared to your significance level, and then your significance level and the p-value together will tell you whether or not you reject the null hypothesis. And that is how you answer the question. It's a big list of steps. These are just parts of them, but these are kind of like the smaller basic steps. And so let's practice it. We're going to just state the conclusion of the hypothesis test. Tommaso wants to find out whether he spends more time on average playing computer games than his friends do. His hypotheses are, his null is that his average is 1.2. And the alternative hypothesis is that his average is greater than 1.2. So that idea is that his friends are probably playing at an average amount of hours of 1.2 hours of computer games. And then he's probably trying to prove or determine whether or not he spends more time. This is a one-tailed test where mu is the mean of time and hours per day spent playing computer games. He uses a 5% significance level for his test. Tommaso collects some data and calculates the p-value. So collecting the data and calculating the p-value is its own whole crazy process. But once we get to the end, we get a p-value of 0.065. When we have that as our answer, 5% of a significance level is 0.05 as a decimal. So comparing 0.065 to 0.05, which one of those is greater? Which one of these values is greater? The 0.065 value is greater. So since we're not less than the significance level, we do not have enough evidence to reject the null hypothesis. So that's the only thing that we can say, is that there is not enough evidence since 0.065 is greater than our significance level. We do not have enough evidence to reject the null hypothesis. And that's all we can say. We can't just say that, like, oh, well, then the null hypothesis is true. All we can say with these calculations and like at the end of all of this hypothesis testing is we don't have enough evidence to disprove this. And it's the same way of like saying, okay, well, then this person is innocent. What we say in the courtroom is we don't have enough evidence to prove that this person is guilty. And that's how they determine whether somebody is innocent or guilty. And that's why this idea of innocent until proven guilty comes in, of they might be guilty of something, but we don't have enough evidence to show that they are guilty of what we're looking at. And so we don't have enough evidence to prove that they're not innocent, and so they must be innocent. And that doesn't always work out well, but sometimes it does work out well. It protects the people. It protects a lot of people out there. So yeah, that's what we're looking at here. That's the end of the hypothesis testing. So let's try it again. Maureen is investigating whether the times Tommaso spends playing computer games each day comes from a normal distribution with mean 1.2 and standard deviation of 0.3. She uses a 10% significance level for her test. Maureen collects some data and calculates the p-value to be 0.07. So first of all, our significance level of 10% as a decimal is 0.10. Comparing 0.07 to 0.10, go ahead and tell me which of those values are greater. Our significance level in this case is greater than our p-value, which means we have enough information to reject the null hypothesis. This is a two-tailed test because it doesn't say whether or not it's the normal distribution has a mean that's gotten larger, or maybe the standard deviation got smaller. We're just saying, hey, is it following the standard deviation, or is it following a normal distribution, or is it not following a normal distribution? And that's all we get to say. The null hypothesis is that it is not a normal distribution. So then the alternative hypothesis would be that it does follow a normal distribution. I lied. So sorry. The null hypothesis is that it does follow a normal distribution. The alternative hypothesis is that it does not follow a normal distribution. There is sufficient evidence to disprove that Tommaso computer game time there's enough evidence to disprove that Tommaso's computer game time does come from a normal distribution of 1.2 and a variance of 0.3 squared. So we said that there is enough evidence to disprove that it comes from a normal distribution. And there you have it. That's it. I know this was long today. It's just because of this format. Good job.